Lecture 37, Faults in Structure Maps. Figure A is a three-dimensional model of a normal fault. The fault is represented by the transparent plane with contours of elevation. The horizon that is offset by the fault is colored and contoured by elevation. Red is high and green is low. More negative elevation values mean deeper areas. The horizon intersects the fault from the hanging wall block and from the footwall block. The lines of intersection of the horizon with the fault are called the hanging wall cutoff and the footwall cutoff. Figure B shows the structure map for this situation. The horizon is colored by elevation, and the hanging wall and footwall cutoffs are drawn in red and blue, respectively. The cutoffs define a fault polygon. Within the fault polygon, the horizon is not present. The elevation contours within the fault polygon are the structure contours of the fault. The fault dips southwest. Figure A is a three-dimensional model of a reverse fault. The fault and the horizon that is offset by the fault are colored by elevation. Red is high and blue is low. More negative elevation values mean deeper areas. Contours in the hanging wall block are continuous lines, and in the footwall block they are dashed lines. Figure B shows the structure map for this situation. The hanging wall block is denoted by the continuous contours, and the footwall block by the dashed contours. Remember that more negative elevation values mean deeper areas. The hanging wall and footwall cutoffs are drawn in red and blue, respectively. The cutoffs define a fault polygon. Within the fault polygon, the horizon is repeated. The elevation contours within the fault polygon are the structure contours of the fault. The fault dips southeast. This is a structure map for a normal fault offsetting a horizon. Contours are elevation and more negative values mean deeper areas. The hanging wall and footwall cutoffs are marked in red and blue, respectively. The elevation contours inside the fault polygon are the structure contours of the fault. The fault dips southwest. The horizontal distance of the orange line, which is traced perpendicular to the cutoff lines, is the fault gap, in this case 24.9 meters. The horizontal distance of the green line, which is traced perpendicular to the structure contours of the fault, is the fault heave, in this case 25.6 meters. The fault throw is the difference in elevation between the end points of the green line, in this case 32 meters. So, the fault heave and fault throw are measured in a direction perpendicular to the strike of the fault. Also notice that the fault heave is not the same that the fault gap. This is a structure map for a reverse fault offsetting a horizon. Contours are elevation and more negative values mean deeper areas. The hanging wall block is denoted by continuous contours, and the footwall block by dashed contours. The hanging wall and footwall cutoffs are marked in red and blue, respectively. The elevation contours inside the fault polygon are the structure contours of the fault. The fault dips southeast. The horizontal distance of the green line, which is traced perpendicular to the structure contours of the fault, is the fault heave, in this case 34 meters. The fault throw is the difference in elevation between the end points of the green line, in this case 3.6 meters. What is the fault throw and heave on this map? What is the stratigraphic separation? Again, contours are elevation and more negative values indicate deeper areas. To determine fault heave and fault throw, we need to trace structure contours on the fault. The red lines in this figure are the -8,500 and -8,900 feet contours on the fault. The fault dip direction is perpendicular to the strike and it is shown by the blue arrow. The fault dips south. Throw and heave must be measured along this direction. Heave is the horizontal distance between the two blue points. It is about 390 feet. Throw is the vertical distance between the two blue points. It is about 450 feet. The stratigraphic separation can be estimated by projecting the contours from the footwall block to the hanging wall block. This is the dashed green line in the figure. The vertical difference between the end points of this dashed line is the stratigraphic separation. It is 400 feet. This map shows a fault that dips to the south. The dashed lines are structure contours on the fault, and more negative values are deeper areas. From the hanging wall and footwall cutoffs, one can see that the fault throw, fault heave, and fault gap vary along the fault strike. Remember, the fault throw and heave should be measured along the dip direction of the fault, which is south. The gap is measured perpendicular to the cutoff lines. The stratigraphic separation is the difference in elevation between the end points of contours projected through the fault polygon. These are the green dashed lines in the figure, and the stratigraphic separation is constant along the fault and equal to 500 feet. How do we make structure maps for normal faults? This is an example. First, we need structure contours on the fault as shown in the left figure. The contours are elevation and the fault dips to the east. The circles with numbers are wells. The first number at each well is the stratigraphic separation in feet. In this example, it is 400 feet. Then, we need contours on the horizon, as shown in the right figure. The horizon has the shape of a dome. Then, we superimpose the horizon and the fault, as shown in the left figure. And look at the points of intersection of the horizon with the fault, as shown in the left figure. Since the fault dips east, and the horizon intersects the fault from the west, the line joining the points of intersection of the horizon and the fault must be the footwall cutoff. On the figure to the right, we trace contours with the same trend, east of the footwall cutoff. These contours are indicated by the dashed lines. Since the stratigraphic separation of the fault is 400 feet, the dashed contours to the east, which are in the hanging wall block, must be 400 feet lower than the contours to the west. We then superimpose the fault to the dashed contours of the hanging wall block, or downthrown side, as shown in the left figure. And look at the intersections of the horizon in the hanging wall block with the fault. These are the red dots in the left figure. The right figure shows the completed structure map. The hanging wall and footwall cutoffs define the fault polygon. For reverse faults, the procedure is similar. We start with structure contours to the fault. In this case, the fault dips west. Then, we superimpose to the fault the structure contours of the horizon in the hanging wall and footwall blocks. The red dots in this figure show the intersection of the fault surface with the horizon in the hanging wall block. These dots delineate the hanging wall cutoff. And the blue dots in this figure show the intersection of the fault surface with the horizon in the footwall block. These dots delineate the footwall cutoff. This figure shows the completed structure map. The hanging wall and footwall cutoffs define an area of fault overlap, where the horizon is repeated. Often in structure maps of reverse faults, the footwall cutoff and the area of overlap are not shown. However, it is important to understand that on the map, there will be an area where the horizon is repeated. That's it. To practice this part, answer these questions.